All right, good day class. We're going to do lab 1-4. This is Ohm's law, I versus E. The objective of this lab is to demonstrate the relationship between current and voltage with a constant resistance. The equipment we're going to use here is our lab bench. We have a tapped resistor here and we have connecting jumpers. I've also installed some fluke multimeters here in order to give us a little bit of a better indication than maybe what you would have been able to see in the analog meters that they asked you to connect up. So the circuit that they ask us for in your lab book in figure 1 right here, it utilizes, coming out of the negative, we head to the DC ammeter. So that would be this guy here. So we're coming out of our negative terminal and heading to our DC negative on this side, okay, of the ammeter. Through that ammeter, and I've got it set at the 10 amp range. Out of that ammeter, we're heading out to our tapped resistor, which is this guy here. Through this tapped resistor, and then back to positive there, as well as I have a voltmeter here in parallel with my load itself. Okay, so this voltmeter here is connected across that tapped resistor. So what they're going to ask us to do is to energize this circuit, and it says note, do not exceed the range of the meters. We're not going to have to worry about that. We're not going to get over 10 amps in the current, and the voltmeter can certainly handle up to 100 volts here. Not a problem, but we're going to ask us to take our voltage up to in 10 volt increments and record the current that we see. I'm going to zoom the camera in a little bit tighter on the meters themselves so that you can see what goes on here. That should be good to give us a display. Okay, so I'm going to power up. I'm going to then start to increase. You can see that this is my voltage, that's my current. I'm in DC amps and DC volts here. I'm going to start to increase my voltage until this indicates 10 volts. So we're about a little over 10 there, 10.09. And we've basically got 100 milliamps there, or 0.1 amp. Okay, so I'm just going to record 0.1 amp. I'm going to then increase it to 20 volts. Pretty close, 20.1. We'll touch it down a teeny bit. It's very touchy at this value. 19.9. I can't get it right at 20. Well, we're close there, 20.1. And we're at basically 200 milliamps, or 0.2 amps. Okay, and you can see where this is headed. If we've got the same fixed resistance, every 10 volts we should increase by another 100 milliamps. So at 30 volts, which is about there, we've got 300 milliamps. Or 0.3 amps. Okay, and I'm just going to keep going here to our 40. Ooh, we jumped from 39 to 43 real fast there, don't we? We're at 0.4 there. Okay, 50 volts. And we're at 0.5. 60 volts, we're at 0.6, and we'll just keep going with this process here to our 70 volts, which is there, 0.7, 80 volts be 0.8, should be anyways, 0.8 there, 90 volts, 0.9, and 100 volts will give us basically 0.988. Well, I'm going to round it up to 1 amp. Okay, and then they're going to ask us to use the attached graph sheet on the back in order to plot what we see there, and then we'll do some observations and conclusions. So I'm zoom back out again so you can see me. All right, so that was lab, what is that? Lab 1-3 or 1-4, Ohm's law, I versus E. So if we were to look at this, we could see that every time we increased the voltage up, the current increased at the same rate, directly proportional. Reason for that is we had the same fixed resistance there. Okay, we'll talk about it in the Learning Hub. Until then, I'm powering down and we'll see you later.